Hey everyone, welcome back to another episode. Today we're going to be doing the camera and player movement scripts. Why do we need camera movement? Well, we're going to make it a smooth camera movement rather than jittery. Anyway, I hope you guys enjoy, and let's get started. So in the last episode, I taught you guys how to make something like this. Obviously, I did this off camera. I redid the level. I actually added some cracked tiles here. We do need to fix there's a little bit of artifacts going on there. But we made our tile map and we can make maps with it. So I just quickly went and made one of these. I also added a few extra details onto the tile map that everyone can use. It's posted on itch.io. The link is in the description. But pretty much what we need to do is we need to add player movement now and camera movement. So let's actually just get started now. Let's create a 2D object as sprite and we'll make it a square. Now, as you can see, it's actually behind everything. So what we need to do, so let's just put these on the default layer for now. Alright, so the player is now here. Let's go in the tags and let's give the player a tag and we'll just call this person player. Let's just close that. Cool. So on this player, we want a few things. The main thing we want is a rigid body 2D, and we're going to disable the gravity by setting it to 0, and then go into constraints and freeze the rotation, not both positions. Cool. So now this is ready for us to do. Next thing we're also going to actually do is just increase the size of the player, so it's a more, I guess, humanoid type shape. It's more rectangular. Another thing that we're going to do is we're going to put on a box collider. Box collider 2D. I don't know why I said square collider. And I'll just check the shape. Yep, it's covering it. But actually what we're going to do is we're going to take the top part and drag it down, because that better represents where the player would be standing. So then we can get these cool looking things. Next we're going to set the order and layer to 1. Let's just see if that works. Yep, so they'll go over the top of those. And the next thing we're going to do is we're actually going to set on the walls, we're actually going to give it a tile map collider. Yep, we'll check these. Cool. Alright, let's next create a player movement script. Okay, let's go add component, and we're going to go player movement. Capital M there. New scripts. We're going to go create and add. Drag it into our scripts folder. And let's open it up in Visual Studio. Alright, so let's actually define a few variables here. So let's go make a float called speed and a vector. No, we don't need a vector 3 here. We need a rigid body 2D called RB. Alright, in the start method, we're going to go RB is equal to, we're going to get the component of rigid body 2D. Now what we can actually do, a little bit of advanced work here. This is what I always do. We can go if get component rigid body is equal to null. Then we can also set else inside the if statement. If it's equal to null, we're actually going to add it. I'm gonna go game object dot add component rigid body 2D. There we go. And what we can also do is then inside here we can go get and then we can set rb.get component. So not an else, sorry, remove the else. Cool, there we go. Underneath rigid body inside the if statement, we're going getting the rigid body. We're going to go rb dot gravity scale. I think we got to do that is equal to 0. Cool, and then the next thing we can go is rb.freeze rotation is equal to true. Cool, that actually should be it for those. And then what we can also do is get the box collider. If get component box collider 2D is equal to null, then we can simply game object dot add component box collider 2D. There we go. Alright, so that's sort of the initialization of it. Next, we're gonna make an update method. Cool. And now we can define how it moves and whereabouts it moves. So let's add a float in the update method, and let's call it x, and let's set it to equal input dot get axis. And then we're gonna go horizontal. And then we're going to multiply it by speed. And that should be it for that part. Next, we're going to go float y is equal to input dot get axis. And this time we're going to be using the vertical axis, because this is going up and down. Then we're going to also multiply it by speed. Alright, so we've got these variables now that we're going to pretty much move our player with. The next thing we need to do is actually make a vector2, and let's call it velocity. We'll call it velocity, or move by. Let's set it equal to a new vector2, and let's go input our x and y. Next, all we have to do down here is go rb.velocity is equal to velocity, and we're actually done with the script. It is as easy as that. Gotta compile it. The gravity scale is supposed to not have a capital G on it. Okay, so then that should be all done. Now we've actually got both of these on here. So let's actually give this a test out and see if it works. The speed's set to 0, so we actually need to make that public. There we go. Let's set the speed to something like 3. See how fast 3 is. And as you can see, we've got a little character movement. Now, when we add a player sprite, we're actually gonna need to make it flip each time that we move with it. So let's actually quickly drag the main camera onto the player so we can just get a basic sort of movement with the camera. And let's increase the player speed to something more like 6. Now let's click play, because we can just move fast. Cool, so as you can see, we can move now. Go through, but the camera's very jittery, and we don't really want that. We're gonna alert between 2 locations. That's essentially what we will be using to do this. But as you can see, I can move around, I can do all this. We're also gonna make zooming in, so with the scroll wheel, you can actually zoom in and out of your player. Okay, so let's go back to our script now. And as you can see, we need to get the reference of the Sprite Renderer, because that's the one that has the flip X and Y. Now we're going to be using flip X for this. Okay, let's make a reference to this. So we're going to make a Sprite Renderer, and we're going to call it Renderer. Make it simple. And then what we're going to do is if get component, do the same here. Sprite Renderer is equal to null. Then we're going to game object dot add component. Sprite Render. Cool. Now outside we're gonna go renderer is equal to get component of Sprite Renderer. Cool. So now we pretty much need to check when we get positive and negative movement, because that's obviously when we want to move and flip our character. So let's check this. So if we go if x is more than 0, we will set renderer dot I think it's flip x is equal to false. That's default when it's positive. Then we can go else if x is less than 0. We can go renderer dot flip x is equal to true. And that should actually be it. So if we come back into Unity now, and we keep an eye on the Sprite Renderer, and we click play, as you can see, it's going to default, it's just going to keep the same. But as soon as we go to the left and right, it's actually going to change back and forwards of being on and off. And that's actually good. That's what we want. We're going to make camera movement. Now this actually is pretty quick and easy, to be honest. We're going to create a folder, and we're just going to call this player and camera. There we go. So all scripts related to player and camera are going to go in here because they are closely related to one another. Cool. Let's now go remove the camera from the player, drag it somewhere, and what we're going to do is going to create a new component, and we're going to go camera movement, new script, and we're going to go create an add. Now let's just drag it into our scripts folder. Cool, and let's just quickly save the scene. So when we get into the camera movement, we're actually just going to get a few values. So let's go a public transform, and we're going to go follow target. And that's what obviously is going to be a player. Next, we're going to make a public vector3, and let's call it offset. And let's also make a public float, and we're going to go move speed. Well, actually smooth speed. Cool. So let's quickly go fixed update for this. And what happened there? Fixed update. There we go. Alright, let's make a vector3 is vector3 position trap or target pos is equal to follow target dot position plus offset. And there we go. Okay, so this is what we're gonna aim for. So now what we can do is transform dot position is equal to vector3 dot lerp between, I'm using capital T's, transform dot position and follow target, not follow target, we're going to be using target pos with the help of the smooth speed. Cool, so let's save this and let's see what happens. That's all good. Let's drag, it's actually already on the camera. Alright, we're going to quickly set this maybe to a 0.1, we'll see what happens when we do that. And if we already look at the camera, it has an offset of 10, so we're going to quickly set the Z offset as negative, the variable follow target, ooh, we got to set one. There we go, let's click play again. And as you can see, it's actually moving towards the player at a very smooth rate, and it gives this really nice sense of smooth gameplay. We can actually turn this up to make it a little bit more snappy if we need to, but even someone like 1 still smooths it out and makes it all nice. I'd prefer someone like 0.5 maybe, where we have that little bit of lag, but even someone like 0.1 still looks really nice. No. Okay, the next thing we're actually going to do today is going to create one more script, and this is going to be the player stats script. So this is what's going to hold the health, damage, and all the stats and buffs and all that kind of stuff the player has. So let's make this player stats. Okay, cool. So we can just define a few variables with this. Straight off the bat, let's just delete the start and update method. We can add them later. Cool, let's make a public. Oh my god. Public string, and we're going to call this name. We're going to make a public int, and we're going to call it level. We're going to make a public float called XP. Or current XP, actually. Public float. Oh, actually, this will be a private one. XP to next level. And we probably will be using the UI components afterwards. So let's go Unity engine.ui. Cool, so we've got a name, a level, a current XP, XP to next level. Now we can add some extra float called health, current health. And I'm going to default this to 100. Then we're going to make a public float called max health. And we're going to set this to 100 to be base. And then we're also going to make another public float called min health. Now, this is a little bit weird, and you wouldn't really expect health to go, you know, above or sorry, below minimum health, but it can actually just help, especially when we're dealing with later game items, if we're gonna add any. which maybe prevent the player from dying, and you just want to set the min health to 1 instead, or even debuffs which make the health worth less. Instead of decreasing the max health, you'd actually increase the min health instead, and then it just makes it a little bit harder for people to, or a little bit easier for people to die. Cool, so let's now in the start, we'll actually update. We'll just go fixed update again, or wait, no, update. Cool, we can go current health is equal to mathf.clamp, and we're gonna go current health between min health and max health. Cool, so that's good. And then we're gonna actually make a public void, and this is gonna be called die, and this is what's gonna happen. This is the function that's gonna happen when you die. So function occurs when death, when health less than or equal to 0. Cool. By the way, all of these scripts that I'm writing right now will be in my itch.io. Just free to download if you guys want them instead of having to code. Entirely up to you. Cool. We can actually go if current health is less than or equal to min health, then we can die. And right now we're just gonna go debug.log dead, just for a basic one, when we set up the damage and all that kind of stuff. Another thing we might want to do is we might want to go public float magica or magic. What would we call it? Magic, or energy. No, we'll call it magic. Public. This will be the one from before. We'll call current magic float max magic in a public float min. Then we can also clamp the current magic is equal to mathf.clamp between current magic between min magic and max magic. There we go. Okay, so the last thing we probably need to do is under camera movement, I actually forgot that we need to add a scrolling. So what we can do is we can make a reference to the camera, public camera, cam. Now if we go back to the scene, and we click on the main camera, just one little thing to prevent getting this error here, what you might want to do is go under the player stats, and instead of name, you can go player name. It just stops that from coming up. I don't know what this is though. On enable. I don't know. Anyway. Okay, so in the camera movement, let's go, as you can see, if we click on the main camera, it comes up with size. Now, size is actually determining whereabouts the camera is, like, how far away it's looking from. So if we go all the way back here, you can see all of this. But all at the front, you can see all this. You can even invert it in the negatives, and the whole thing gets flipped upside down. It looks weird. But yeah, this controls how big everything looks. So we probably want to clamp it between maybe a value of 10 and 2, or maybe 3. But we want the mouse scroll wheel to be the one that changes it. So let's go and make this. We can make a public float called min size and a public float called max size. And then we can just make a private one, or even just a float called size or current size. I prefer using current in front of things, just helps me understand it. Cool. So now what we can do is we can go current size is equal to input, or actually is plus equal to input dot mouse scroll plus is equal to input dot mouse scroll delta dot y. And then we can actually multiply this by a public float called scroll speed multiplied by scroll speed. And let's save this and let's go back. Oh, actually no, we need to assign it. So let's go cam.size is equal to current size. And just to prevent it from going too big or too small, let's also go current size is equal to mathf.clamp between current size between minimum size and maximum size. Well, let's save this and go back. Camera does not contain a definition for size. Let me guess it's capitalized. So I just actually realized that cam.size isn't an actual thing. We actually have to go orthographic size. I probably spelled that wrong. Orthographic size is equal to current size. Oh, no way. Sick. Cool. Let's now change all of these. Okay, let's drag in the main camera for that. Scroll speed. Oh, we'll just set that to 1. Minimum size is 3. Maximum size is 10. Yep. And then what we can also do in the start method, we can actually set cam is equal to get component of camera. Let's go back. Cool. So now let's go back and let's play and let's see what happens. Cool, so as you can see, when we scroll, we're actually changing how far away the camera is. So I think scroll speed should be a little bit less. I just changed fix update to update because I realized that fix update happens at a constant time. If you just set it to regular update, it does fix itself. Although, this is jittering a lot, so what we might want to do is set this to fixed update, but let's also make regular update as well. And let's put all of this inside regular update instead. Problem solving. Cool, now let's restart our game and let's see what happens. Cool, so now we have this smooth camera zoom in, zoom out. Actually, it's pretty simple. So this is actually really jittery, the zooming in and out. So what we probably want to do is make it slightly less like that and less jarring to look at. Jesus Christ, I hate that. Don't get me wrong, it's very helpful, although it is very jittery. We probably need to lerp it. Okay, so what we're going to want to do for this is, instead of current size, we're actually going to set this to target size. And let's also create the float, and let's call this current size. Cool. So what we need to do is when we increase this, we're actually increasing the target size instead of the current size now. And when we get to this is also going to be different. So what we can actually do is remove these. That stays in update. Let's just pull this up before fixed update. So it makes a little bit more sense. Cool. So now in fixed update, what we can do is we can go current size is equal to mathf.lerp between, we can actually go float size smooth speed. Cool, and what we can do is we can go lerp it between the current size and the target size, and then we can remove it by side smooth speed. Current size is equal to mathf.clamp current size between minimum size and maximum size. Cool, now that actually should work, so let's actually paste these in now at the bottom here, and let's pull that up here. Oh, cool, we're all good. And let's remove that up there so it doesn't set it before it sets it up here. And I think that's actually good. So let's go ahead and play now, and let's see if it works. I've probably missed something. Let's set this to 0.5, just so we can visibly see and it's not too slow. I've definitely missed something here. Okay, so the actual problem that we're facing is that it's actually not clamping it, which is interesting. I think we should probably clamp it up here, clamp the target size, because that's what it's trying to aim for essentially. So let's change this to target size and target size. Cool. So that actually should fix it now. It is working though. That's what we needed to know. Let's set the smooth speed to 0.1 so we can easily see it. Now let's click play. And it should be nice and smooth like the player movement. Oh, look how nice that is. Zoom in and out and it looks so goddamn smooth. Anyway guys, I hope you guys enjoyed the episode. I'll see you guys... My god, I keep saying guys a lot. I'll see you boys next time, boys and girls, fellow game developers. Hope you enjoyed, and I'll see you next time.